While everyone was waiting for a breakthrough with Tesla Bot 3, the team at Boston Dynamics managed to outdo everyone again. At a recent expo in Las Vegas, company CEO Robert Plater announced that mass production of the Atlas Humanoid is now underway. It's what Elon Musk has been promising for years. But behind that big announcement, most of the press missed one key detail. The entire 2026 production run isn't just planned, it's already sold out. But how did this become possible? What's the secret behind the new robot? Why are companies lining up for it at a price that's 10 times the price of Optimus? Who's buying it? And most importantly, why did the tech giant Google and the investment empire SoftBank fail miserably to monetize Boston Dynamics while Hyundai, of all companies, managed to pull it off in just a couple of years? What's going on with robots right now? Tesla Optimus has been promised for years. Figure AI regularly releases beautiful, rehearsed demos filmed in ideal laboratory conditions. Unitree makes robots for $20,000, but they're controlled like RC toys, with a remote. And they know how to wave their legs, not how to work. Boston Dynamics is a completely different story. This isn't a startup that raised a round of funding and drew pretty renders. This is over 30 years of engineering obsession, 4 ownership changes, 2 governments, and 1 nuclear disaster that started it all. Wait, a nuclear disaster? Yes, exactly that. On March 11th, 2011, a magnitude 9 earthquake caused a tsunami. A giant 15-meter wave covered the Fukushima 1 nuclear power plant. The consequences were catastrophic. The reactors failed, radiation started leaking, but the most shocking thing is that the damage from the disaster could have been minimized if people had machines capable of going in there. It's an uncomfortable fact, but despite all our technological progress, there were no machines ready to go. The environment was built for people: stairs, doors, tight corridors, and countless valves that have to be turned by hand. You can't send humans in. It's a death sentence. No suit will protect them. So Japanese engineers tried sending robots in instead. Military-grade hardware built for disaster zones should have been perfect, but it failed the moment it faced real-world conditions. The tracked packbot produced by iRobot, yes, the same iRobot that makes robot vacuum cleaners, got stuck on the very first staircase. The other machines weren't much better. Some couldn't open an ordinary door. Others lost connection after 10 minutes because of radiation interference. In the end, a basic door handle turned out to be the obstacle for the most advanced robots at that time. The disaster became a signal, and the first to react to it was DARPA, the Defense Advanced Research Projects Agency of the US Department of Defense. They came to a simple conclusion: we need robots with arms and legs. Not because it looks beautiful, but because the world is built for humans, and only a machine with a human form will be able to work in it. With this goal, the DARPA Robotics Challenge was announced in 2012, an open competition to create a humanoid rescue robot. The tasks were simple. For a human, climb a ladder, open a door, drive a car, work with tools. Boston Dynamics participated, and their robot took second place. From that moment on, Atlas stopped being a laboratory experiment, but the path to a truly useful robot was still long. And here's the central question of this video: how did a car factory solve a problem that neither DARPA, nor Google, nor SoftBank could solve? Why did they hit a wall for years and only Hyundai managed to bring Atlas into mass production? The answer is much more prosaic and at the same time more elegant than you think. But to understand it, you must first understand why everyone else failed. And the history of these failures is much more interesting than it seems. Let's start from the beginning. Mark Raibert founded Boston Dynamics in 1992 as a spin-off from MIT. He was obsessed with one task that seems simple until you start thinking about it seriously: making a machine walk on 2 legs. Unlike a wheeled robot, a walking robot's center of gravity shifts with every step. Dozens of joints must be controlled simultaneously. One mistake and the machine goes down. Maintaining the dynamic balance of a bipedal system is one of the most complex real-time control tasks that exist. Raibert found an elegant approach. Don't program every movement rigidly, but use physics instead. Let inertia and gravity themselves help the robot walk. The controller corrects rather than dictates. This is the principle that lies at the heart of all good walking machines today. But experiments need money, and it came from where they don't spare funds for breakthrough ideas: from DARPA. According to available data, since 2008, the agency has sent Boston Dynamics about $200 million. To understand the scale, that's roughly the price of 2 F-35 fighter jets. And they spend it not on weapons, but on the dream of a walking robot. These colossal funds went into building Big Dog. The 4-legged robot weighed about 240 pounds, 110 kilograms, and could haul roughly 330 pounds, 150 kilograms of gear over almost any terrain, all while following a human handler. The 2009 video of it getting kicked and instantly regaining its balance went viral before the word viral was even a thing. Of course, the army became interested in this and conducted tests, but they were declared a failure. Why? It's simple. The robot handled its tasks perfectly, but it made so much noise that any enemy would hear it a mile away. It's like walking with an orchestra, notifying everyone of your movements. That's not a tactical advantage, it's a tactical disaster. In the end, $200 million, the best balance in the world, and a 330-pound payload capacity, and it all failed because the gas engine was just too loud. Classic defense R&D. But the company didn't give up and used the developments from Big Dog to create a bipedal platform. So by 2013, the first Atlas appeared on the scene. Back then, it was still more prototype than product, but it already had the main thing, the ability to keep its balance on difficult terrain even under impact. For that time, it was something unheard of, so it's no surprise that Google bought the company right away. And suddenly, the story becomes truly instructive here. For the IT giant, the purchase wasn't spontaneous. Google saw the birth of a new market and launched a large-scale acquisition program of robotics companies under the leadership of Andy Rubin, the same guy who created Android. In just a few months, they acquired Boston Dynamics, Shaft, Industrial Perception, and Redwood Robotics. A whole robotics division appeared, which, by some estimates, cost over $500 million to create. The idea was grand, to create the next platform business after smartphones. Robots in every home and every warehouse, powered by Google. It sounds like any business's dream. But then the problem started. The first one was ideological. Boston Dynamics made robots for the military and research labs. Their vision was engineering excellence, impressive demos, and minimal commercial responsibility. But Google wanted a product, scale, and monetization, and preferably within 3 to 5 years. The companies literally existed in different worlds that just didn't intersect. The second problem was reputational. In 2013, an internal Google email leaked where employees complained about Boston Dynamics' disturbing image. Videos of Big Dog were getting millions of views, and they were literally scaring people. People online wrote, "It's Skynet, it's the end of humanity, and deadly war robots are coming." For a company that was already fighting regulators around the world, this was just an extra headache. But the main problem turned out to be the third one. Google doesn't have factories. It seems so simple, thinking about something like that in advance. But just remember, Google is about ads, data, and the cloud. The company doesn't have manufacturing facilities, it doesn't have a hardware supply chain, and it doesn't have engineering departments that know how to scale a physical product from a prototype to thousands of units a year. They know how to create and scale software, but not hardware. For a robotics company, this is a fatal flaw in the buyer's structure. In the end, in 2017, after 4 years of trying to create a commercial product, and after Andy Rubin's departure due to internal scandals, Google sold Boston Dynamics to the Japanese conglomerate SoftBank. A new era began for the company. SoftBank is a story all by itself. Masayoshi Son, the founder and CEO, raised $100 billion for his Vision Fund in 2016, the largest tech fund in history. His strategy was to bet on companies that would dominate the market for the next 30 years. Uber, WeWork, Arm, DoorDash. SoftBank got into everything all at once. Naturally, they went for the most technological and innovative stuff. Boston Dynamics fit perfectly into the ideal picture of the future and the narrative about intelligent robots. But SoftBank had the same problem as Google, only even more acute. They're financial investors, the biggest and richest, but still investors, not manufacturers, not an engineering company. They know how to give money and wait for the value to grow. They needed an IPO or a sale at a premium. As a result, SoftBank spent 4 years looking for a use for Boston Dynamics. They tried to force the company to speed up with a commercial product, and we're grateful to them for that because that is how the new Spot was born. A small, 4-legged robot with incredible stability and maneuverability that could finally be sold to businesses. By 2020, Spot went into production at $75,000 a piece. This was progress, but it was slow, as the robot had to find its place in the market and prove it would be useful. At the same time, Atlas remained a research platform without a commercial future. Because no amount of money from SoftBank could solve the fundamental problem, a hydraulic Atlas cost between $1 and $2 million per unit. And on top of that, it required constant maintenance by a team of engineers. That's not a business, that's a hobby for governments and research universities. In the end, in 2021, SoftBank gave up and sold 80% of Boston Dynamics to Hyundai Motor Group for a whopping $1.1 billion. And here we should stop and think. A car factory buys the world's best robotics company, which neither Google with its $500 million for robotics nor SoftBank with its Vision Fund could monetize. Either it was a stroke of genius or a very extravagant way to throw $1 billion down the drain. Let's break it down. While Google and SoftBank were looking for a business model, something else important happened in the world. From 2018 to 2022, there was a real Cambrian explosion in robotics. The jump in technology and the interest in robots, sparked by Boston Dynamics videos, led to the emergence of Figure AI, 1X Technologies, Apptronic, and Agility Robotics. Dozens of startups started receiving hundreds of millions of venture capital dollars, promising to realize the same idea: a humanoid robot for industry that would solve all staffing problems. To be fair, we have to mention Elon Musk's contribution to this boom. At the moment when people started saying that the Boston Dynamics Atlas was only good for stunts and that robots were an unattainable dream, he stepped onto the stage and shook the world. Musk announced that he would create a robot for the price of a car, and that it would become the company's main product. From that moment on, everyone believed in a future with robots. Some with all their heart, others just in case. As a result, every auto giant started looking closely at robots. Mercedes-Benz took a stake in Apptronic. BMW started testing figure robots at its plant in South Carolina. Toyota put Agility Robotics Humanoids on the assembly lines of its Ontario plant. The race has officially begun. And Hyundai had its own strategy in it, the only one that made sense. By the time of the deal with the auto giant, Boston Dynamics had the hydraulic Atlas. This piece of engineering art possessed incredible stability, balance, and the ability to control its own body. Videos of backflips, parkour, acrobatic stunts, and dancing were racking up tens of millions of views. However, experts estimated the cost of a single robot at between $1 and $2 million, and that was with the design being fully optimized. Many body parts were 3D printed and included hydraulic channels right from the start. Engineers thought through every inch to give the robot maximum strength with minimum weight and, whenever possible, to protect it from braking during falls. The Atlas equipment included top-of-the-line LiDARs to create a three-dimensional map of the space. Balance sensors allowed it to feel tilt and the speed of body position changes in real time. Powerful onboard computers calculated the most complex trajectories in an instant. It was a stunning machine, and absolutely unprofitable. Besides the sky-high cost, the robot was completely impractical. After all, hydraulics leak. Hoses easily tear off during a fall. This requires constant monitoring, and there is no way you could launch mass production of such a machine without a team of engineers constantly tagging along. A robot like that is not a product, it is a laboratory setup. But Hyundai looked at all of this and saw an opportunity rather than a problem. Here's a fact that Boston Dynamics competitors really don't want you to know. The most expensive component in a humanoid robot is not the processor at all. It is not the cameras or the sensors. It is not the AI software. It is the actuators, the electric joints and drives that move the android's limbs. They actually make up 30% to 50% of the cost of such a machine, but they're the ones that determine whether a robot can hold an object with the right amount of force, whether it feels resistance, whether it reacts to unexpected contact without braking. Manufacturing industrial-grade actuators that can withstand an 8 or 10-hour shift at a factory is technically difficult and expensive, and all of Boston Dynamics' competitors like Figure, Unitree, and 1X are struggling with this problem with no results so far. Now, do you know what the main engineering achievement of Hyundai Mobis is? The division that has been working on vehicle electrification for 15 years. Yeah, you guessed it right, it's actuators. The thing is, the architecture of electric actuators for humanoid robot joints is very similar to a car's electric power steering. Both systems use an electric motor, a gearbox, sensors, and a controller. Some engineers estimate this similarity at 60%. That is quite a lot. And Hyundai Mobis, for the record, produces electric power steering units in massive volumes. And it's all done according to proven standards through global supply chains with aviation-level quality quality control. They didn't invent a new actuator. They took what they already produced by the millions every year and adapted it for the robot. That was the exact moment the equation finally had a solution. Google couldn't do it because it didn't have the factories. SoftBank couldn't do it because it didn't have the manufacturing. Hyundai could, because the necessary component was already sitting in their warehouse. It's just that nobody had thought of using it. Now let's take a look at the product that came out of all this. The new Atlas wasn't designed in the image of a human. Why limit a machine to the capabilities of our bodies? Or give it such thin, fragile fingers? Instead, the engineers created a robot that fits into human environments but surpasses them in capability. The result is a machine 6.2 feet tall, weighing 198 pounds with an arm reach of 7.5 feet. The new Atlas has 56 degrees of freedom. For comparison, a human, if you take a simplified skeleton and don't count every movable vertebra, facial expression, or fine motor skill, has about 40 to 50. But the Boston Dynamics robot has a unique superpower. It can rotate many of its joints 360 degrees. And that's pretty convenient, right? It doesn't need to turn its whole body around, it can just rotate its torso, or its wrist. When you see something like that, you start to doubt that we're the pinnacle of evolution. The Atlas's lifting capacity is 110 pounds at its peak, and 66 pounds for constant repetitive operations. At the same time, it's got tactile sensors in its fingers and cameras in its palms, in addition to a general 360-degree field of vision. The robot always sees its surroundings, not just the racks and the conveyor belt. If a person walks within a certain radius, the robot stops and waits for them to pass. The robot also has an IP67 protection rating. That's the same standard as your expensive smartphone, except in the case of the Atlas, it means it's not afraid of a pipe bursting in the shop or a dust storm on a construction site. It'll withstand an accidental blast of water from a hose during cleaning, and its operating range is from -4 to 104 degrees Fahrenheit. As for the operating time, it's limitless. Yeah, exactly. One battery lasts for 4 hours, but the robot swaps it out itself in 3 minutes and heads right back to its workstation, all without any human involvement. The company hasn't released official data on the robot's estimated lifespan, but a design based on Hyundai Mobis components implies the same reliability standards as automotive parts, and that is at least 10 years with routine maintenance. Even though the robot's cost is estimated at $150,000 to $200,000, when it works 24/7, it changes the entire economics of the ROI calculation. We have figured out the hardware, but it's useless without brains. So how is Atlas doing in that department? Here, Boston Dynamics bet on partnerships instead of building all the AI in-house. The logic is simple. Why build from scratch what others already do better than you? Boston Dynamics itself is responsible for the body. 30 years of accumulated knowledge in dynamic balance, joint coordination, and spatial awareness is something you can't just buy or quickly replicate. In real time, Atlas builds a 3D model of every object it works with. It's not just I see a part, it's I understand its shape, volume, and physical properties. Google DeepMind and their Gemini Robotics are responsible for the logic. This is a system that allows robots of any shape and size to turn an operator's words and visual input into clear instructions for action. Basically, you tell the machine, clear this off the table and put it in the drawer. And the robot understands the command and executes it, taking the context into account. I mean, it can figure out for itself exactly what to clear and which drawer to put it in. And even what clear off means in principle. Not long ago, this was a huge problem for robots, since natural language commands can be interpreted in so many different ways. What's more, if something falls in the robot's path, it doesn't wait for extra instructions. It just clears it away or goes around it. See what I mean? One command, minimal supervision, and it's all done. But that's for things the robot already knows and understands. Of course, for specific applications, it still needs additional training. And for that, Boston Dynamics signed a deal with another cutting-edge team, the Toyota Research Institute. They're building an incredibly effective system. Imagine you put on a VR headset and demonstrate the required action just once. The neural network doesn't just record it, it extracts the underlying principle, and it transfers that skill to new objects without any reprogramming. Because of this, any robot can master a new task in less than 24 hours. And if one Atlas learns something, its skill is immediately transferred to all its brothers. The Orbit platform, which the Boston team developed for Spot and successfully ported to Atlas, handles this. It's responsible for organizing and managing the entire robot fleet. Orbit doesn't just let you monitor the humanoid, track metrics, and assign new tasks. It lets you connect the robot to any production system. As a bonus, Orbit's visual and language perception models can identify safety and reliability issues, from product spills to trash buildup, and you don't have to pay extra for that. In other words, you buy a robot, take it out of the box, and literally within one day, you connect it to all your systems and send it to work. No instructors, no downtime, it's just ready. This isn't just one smart robot, it's a system that gets smarter with every hour it works and shares that knowledge with every machine in the fleet. That is even more stunning than a backflip. Now let's talk about the money. Boston Dynamics hasn't announced an official price yet, but they've given a benchmark. The cost of an Atlas won't exceed the labor costs of 2 American workers over 2 years. The average salary for a manufacturing worker in the US is about $50,000 a year, including taxes and insurance. 2 workers for 2 years, that's about $200,000. Analysts have expanded this figure a bit and estimate the robot in the range of $130,000 to $320,000 per unit. For comparison, competitors like Tesla Optimus, Figure, and Unitree are aiming for a range of around $20,000. It turns out that Atlas is 10 to 15 times more expensive than them, but unlike them, this robot is already completely sold out. How is that possible? It's simple. Businesses don't look at the purchase price, they look at the cost of ownership. Atlas works 3 shifts, 24 hours, 7 days a week, no sick leave, no vacations, and no demands for a pay raise. No mistakes from exhaustion at the end of a shift. With an estimated lifespan of 10 years, even at the high-end estimate of $320,000, it still comes out to less than $90 a day. Try hiring an employee for that. So, who exactly bought the Atlas robot? The entire volume to be produced in 2026 will be split between 2 buyers. The first is Hyundai itself, which will put the robots on the training floor at the Robotics Meta Plant Application Center in Georgia. The second buyer is Google DeepMind. The company plans to purchase between 2,000 and 3,000 units for its research labs to further develop Gemini robotics. Yeah, you're probably a little disappointed. Training again, but in Hyundai's case, that's not quite the whole story. The thing is, any new technology for factory assembly lines has to pass testing at the RMAC Center first. That's a universal rule, and the Atlas robots won't be an exception. But by 2028, they'll be on the company's assembly lines performing simple, repetitive operations. For example, sorting parts, tending machines, picking orders, and much more. And by 2030, the robots will start the full-scale assembly of auto components. And here's a figure for you, just so you can imagine the scale and the seriousness of the auto giant's intentions. $26 billion. That's the budget of a small country, and that's exactly how much Hyundai intends to invest in US manufacturing, mostly to build a factory for producing humanoid robots. The planned production volume, get this, is up to 30,000 units a year. So Hyundai Motor Group is building a factory that will produce robots so that they can work at other Hyundai factories. It's a closed loop and a new chapter in the history of world industry. Now let's talk about what this means for you personally. Morgan Stanley estimates the humanoid robot market at $5 trillion by 2050. That is more than 1 billion androids deployed in real-world manufacturing and beyond. It sounds like a sci-fi script, but this is a serious forecast from an investment bank. It is built on existing production plans and price curves. The first applications are predictable: heavy physical labor in manufacturing, warehouses, and logistics. 3 factors are converging here at once. First, the global aging of the population and the labor shortage, which will become even more acute by 2030. Second, the economic attractiveness of robots compared to human employees. And third, technological maturity, which 30 years of research has finally turned into a commercial product. The transition won't be instantaneous, and that's important to understand. It's more of a horizon than an apocalypse happening tomorrow. But many experts say we're still adapting too slowly, and we might not have enough time to restructure even if we have a few years left. A few years, just think about that. To be fair, we have to mention the skeptics too. They have their arguments as well. First of all, a demo is not a production line. As Bloomberg rightly pointed out, home robots at CES were painfully slow at something as basic as putting clothes into a washing machine. So what can we say about more serious tasks? A factory environment is more predictable than a home. It's easier for robots to operate there, but reliability issues in practice are a real risk. This is where robots will have to prove their dependability. Second, a price tag of $130,000 to $320,000 makes Atlas a niche product. Small and mid-sized businesses won't be buying it. This is a story for large corporations with long-term planning horizons. Third, the competitors aren't standing still. If Tesla gets Optimus down to $20,000 with acceptable reliability, the economics of Atlas start to look very different. However, these are all arguments about about the pace, not the direction. The robots are coming and nothing is going to change that. But let's go back to the question we started with. How did a car factory solve a problem that neither Google, nor DARPA, nor SoftBank could handle? It's a matter of motivation. Google was looking for the next platform product. SoftBank was looking for a growth story for its fund. DARPA was looking for military applications. Hyundai was looking for a solution for its own assembly line. That's the only incentive that could turn a 30-year research project into an industrial tool. It's not because they're smarter, it's because they had a specific pain point, a specific factory, and the right component was already sitting in their warehouse. What's truly gripping here? The story of Atlas is not just a chronicle of engineering achievements. It is a vivid example of how even the most brilliant technology is dead without the right context and a manufacturing base. Right now, we are entering an era where robots are no longer just stars of viral videos and are becoming a new reality. And while some argue about the pace of adoption, others are building the factories of the future. Perhaps in 10 years, we will look back at 2026 as the beginning of a new era in the economy and in our lives. Are you ready for that world? While you are thinking about the answer, the future is already coming off the assembly line. If you want to see more breakdowns like this, you know what to do. And here's a question for the comments. Who do you think will win this race by 2030? Hyundai with 30,000 Atlases a year, or Tesla Optimus at $20,000 apiece? We are really interested to see what you think about that trade-off.